Grab some water.
Okay, so Jason is beginning lab 1. He's getting all of his materials prepared. Here he has three tools to measure out 1 milliliter, right, Jason?
Right.
What are the 3 that you're going to use to measure out 1 milliliter?
I will be using a pipette, adjustable volume pipette, another pipette, different type of pipette, and a graduated cylinder.
Okay, those are the 3 tools that you're going to use for measuring out 1 milliliter. What 3 tools are you going to measure out for 4 milliliter? Use to measure out 4 milliliters.
I will be using the graduated cylinder again, and I will be using 2 different sizes pipettes. One is a 5 milliliter pipette, and the other is a 10 milliliter pipette.
Okay, and for your 10 milliliter volumes, what 3 tools are you going to use?
I will be using a beaker, a larger graduated cylinder, and a 10 milliliter volumetric flask.
All right, excellent. So those are the 3 tools we're going to be using for the 3 different things. So I noticed that you chose this one. Why did you choose that one?
Because it delivers a very precise 1 milliliter.
And because it's mandatory, right?
Mandatory.
That has to be, for this lab, we have to get experience with our micropipette. Good. Also, I noticed that you didn't choose, you only chose, I mean, you had a little bit of overlap, which is okay. These 3 for your 4 milliliters, and this one also for your 1 milliliter, right?
Right.
Which is absolutely okay as well. They don't need to be 3 distinct tools, and they shouldn't be the 3 same tools either to do the 1, the 4, and the 10, because the tools aren't made that way, right?
Right.
Excellent. Okay, what's next?
Okay, first we need to get some water.
Okay.
Go over here.
Does it matter which water you use?
Yes, we want to use the deionized water.
Okay. What's in the other water?
Other salts and minerals that could change the mass of water.
Okay.
We want to use as pure water as we can get.
All right. For this lab, it's probably not nearly as important as the next labs, but we always use the deionized water, right?
Right.
Okay. All right. Now, how are you going to determine the mass of, or how much volume you actually measure out?
We'll be weighing it. Turn on the scale, the balance. Let it turn on. And then I can use a weigh boat. Weigh boat. Stick it on there. Make sure this is closed. All the windows are closed. Wait for the mass to stop moving around, and then you can press the tare button. See, now it's 0.
All right. So now when you try to measure out a milliliter of water, how is this balance going to help you know whether you measured out that 1 milliliter of water?
The density of water, pure water, is well known. So if we measure out 1 milliliter and weigh it, if the mass matches up with the density of 1 milliliter we'll we can say that we have 1 milliliter water.
Okay, excellent. So let's see it happen.
Okay, now we'll first do micropipette. For that we need the micropipette tips. See that it has an adjustable volume?
Uh-huh.
Make sure it's on 1,000. This is 1,000 microliters, or 1 milliliter. So with a micropipette, you'll notice that there is one stop and then there's a second stop. When you pick up volume, you go to the first stop. Pull up whatever liquid you're dealing with, then you can go over here and then go all the way down through the second stop.
What number should we expect if we measured 1 milliliter?
Close to 1. And that is very close to 1.
Okay, so we measured it out once. Is that good?
No, we need to measure out at least 4 times.
So you're getting on your computer here. Why are you getting on the computer?
So I can create an Excel file, Excel spreadsheet, so I can keep track of all of my measurements. We want to make sure we get good averages, and are we going to be doing standard deviations? And a good standard deviation. Excel is a great tool for this. So right here, and then we had 0.998, and that is of course grams. And then we can measure it again. Instead of emptying the weigh boat, we can just press the tare button again to get 0. Pull up that again. .996. Then we will be doing this 2 more times.
So this is the third measurement, right? Third attempt?
Fourth.
Fourth. This is the fourth.
Fourth and final.
.996. Great. Yeah. All right. So we did it 4 times. What do you do with that data?
Okay, we can make an average here and a standard deviation. And here we just go equals.
So you typed in an equal sign, and then the word average, and then an open parentheses, and then what?
Then you highlight your data.
Okay, highlighted the data,
Close the parentheses.
and then that's the average?
That is the average.
Okay. So how do you do the standard deviation now?
We type in equals, standard dev, parentheses, and same thing. And there's our standard deviation.
All right, great. So are we done with 1 milliliter?
No, we need to use the other 3 tools.
Okay, other 2 tools, right?
Other 2 tools.
Right. Which are, again, what did you choose?
A pipette,
Is that a 1 milliliter
1 milliliter,
pipette?
and a 10 milliliter graduated cylinder.
10 milliliter graduated cylinder. Great.
So
How do we get water in that pipette?
we can use a pipette.
A pipette pump?
It's a pipette pump.
All right.
Up and down.
Mm-hmm.
Pull it off. So on the pipette, you will notice that the numbers go from 0.9 all the way to 0.
Uh-huh.
Go to 0 to measure out 1 milliliter.
Okay. And then on the other side, no, not on this one. Okay,
Not
great.
on this one.
Excellent. Perfect. Is it important to pull it out of the water when you get your final value? If you leave it in the water, then the water pressure will kind of push up the water in the pipette, and the meniscus will be a little bit higher.
Right. So when you are actually finding the final volume,
Sometimes you can go a little above it and then expel it out while you're outside of the water or something like that. Okay, you got it?
got it.
All right.
So like we did before, we're just going to tear that to get 0 and pour in all of that.
All right. 0.982. Where do we put that in our Excel spreadsheet? Okay, so what do we do here? We make another one of these.
Yes.
So I guess we could copy this and then paste it right here. And now this average corresponds to these values, and this standard deviation still corresponds to these values. We just need to change this word to what? maybe 1 milliliter pipette. Is that okay?
That is right.
And now this value, these values here are wrong, right? So we can delete them. Whoops. But we can put them in as we go, right? Now what number is this?
0.982.
All right, great. So we do that one 4 times, correct?
Correct.
So it looks like you finished your 4 measurements with your second tool for 1 milliliter.
I did.
All right. And the average is 0.9695 and the standard deviation is 0.012. Okay, and so you already made this one as well, the third spot for your third tool. Is that correct?
Correct.
All right, and your third tool is going to be?
A 10 milliliter graduated cylinder.
10 milliliter graduated cylinder. Great.
So we will just be filling it up to there. We want to make sure the meniscus is right at the 1 milliliter. To do that, we will just be, we can either pour it, which is a pain in the butt, or we can use a transfer pipette.
Okay.
You can use a transfer pipette for transferring volume, not a volumetric measurement though.
So not quantitatively.
No.
You don't know how much exactly, but it helps controlling the transfer a little bit, right?
Right.
Okay, so got a little medicine dropper type thing, right? And you're going to fill it up.
Then to see if we have the right volume, we get down at eye level, make sure we're looking at it perpendicular to the water level. And there we have a little less than we need, so a few more drops. Until we got what we need.
All right. Is there anything wrong with having a drop on the side like that?
There could be. It's going to go out with the volume as you pour it. So you want to try to make sure there's as little volume or as little water on the side as possible. This one we can just suck it up.
Excellent. All right, so we're ready to measure it now?
Yeah.
Okay.
So tear that, then pour it in.
.992, that's pretty good.
That ain't that.
All right, and then we repeat that 4 times, correct? Or 3 more?
3 more times.
All right. All right, so you finished with your third tool for 1 milliliter, correct?
I did.
All right. Now, you're going to repeat this for 4 milliliters and 10 milliliters, is that right?
That is right.
And again, we identified previously the tools, but we'll remind ourselves, these are the 3 that you're going to use for 4. And then these 3, this little beaker, volumetric, 10 milliliter volumetric flask, and graduated cylinder for the 10, correct?
Correct.
All right, so you're going to have another one of these. You can copy and paste that whole thing. All right, now we just need to change that to 4 milliliters, correct?
Correct.
Okay, and you're going to change the names there,
So,
and then measure out 4 milliliter volumes with these ones. So you have a, what, the graduated cylinder? Or a 5 milliliter pipette first?
Yep.
Okay.
We'll have a 10 milliliter pipette. And then we will also be using the 10 milliliter graduated cylinder again.
Okay, excellent. So we're all set. Those numbers aren't right, but you're going to replace them with the right numbers as time goes on, right?
Right.
Okay, so you guys know how to use pipettes. He's already showed you that. And you know how to use this. He already showed you that. Could you show us which line corresponds to 4 milliliters on these two, just in case we can't tell?
Okay, on this pipette, instead of just going from the high number down to 0,
Yes?
it also goes from 0 to 4,
Okay.
like we want on
All
this
right.
side. The same for this
So you just
pipette.
fill up to that 4?
Yes.
Okay.
and you should have about 4 milliliters.
All right. And this one here, the other one you say?
It is the exact same.
Okay.
One side it goes from high to low.
Why does it count down on some of them?
So you can deliver that much.
Ah, so if you had it up to here and you were delivering it slowly, you would find out how much you had delivered?
Exactly.
Okay. Okay, great. So you're going to do that for those three, and
Yep.
then when you're done, we'll join you when you're starting your 10 milliliters, okay?
Sounds good.
Okay, great. All right, so it looks like you finished the 4.
I finished the 4.
All right, the 4 milliliters using the 5 milliliter pipette, the 10 milliliter pipette, and the 10 milliliter graduated cylinder. All right, looks good. What's next?
We will be using a 100 milliliter graduated cylinder, a beaker, and a 10 milliliter volumetric flask to measure out 10 milliliters. The 100 milliliter graduated cylinder is the exact same as the 10 milliliter graduated cylinder as far as how to measure the volume out. The beaker, just measure up to that line right there. But the volumetric flask, this will only measure out 10 milliliters. See this line right there? That is the 10 milliliter mark. So at that mark, it is exactly 10 milliliters.
Excellent. Okay, so you're going to do that 4 times each, and same process, right?
Right.
You weigh it out, and based on the mass, you're going to determine what volume you actually measured out.
Correct.
All right, we'll come back when you're done then. All right, so what'd you do?
So I finished the 4 milliliter and the 10 milliliter.
Okay, 10 milliliter, 3 different
Measurements.
tools, 4 times.
Yep. And
All right, excellent. Good job. So now we have the average and the standard deviation, and in the next part, part B, we are going to, like it says, use the following procedure with your best methods to determine the density of water and ethanol. So now we have to determine which one of these tools is the best for 1, 4, and 10, right? How are we going to do that?
We are going to look at the averages and the standard deviations. We want the smallest standard deviation possible.
Okay, so for the 1 milliliter, let's look at those ones.
So the 1 milliliter, it's pretty obvious that the micropipette has the smallest standard deviation.
That one right there?
Yes.
Its average is what?
0.99675, while its standard deviation is 0.000957 grams.
Now this one has a better average though, right? Oh no, that's 0.96, so that's actually lower. Okay, because we're trying to, the density of water is about 1 gram per milliliter, right?
Yes.
So we expect it to be equivalent to the number of milliliters we weighed out, right?
Correct.
Okay, so it looks like this one has the number that is closest to 1, and it has the value that the standard deviation, which is the lowest.
Correct. So as far as 1 milliliters go, we would use a micropipette.
Okay. What about the 4 milliliter ones?
So we can see that the averages are pretty similar. They're pretty close, but we can still see that 10 milliliter graduated cylinder is actually giving us a smaller standard deviation, not by a lot, but it's still smaller. So we would actually use that.
Okay, so looks like based on the way that Jason does things, the 10 milliliter graduated cylinder gives him about the same average as all of them, and only, it's very, very small difference, right? 0.011 versus 0.012 or 0.015. Now, in terms of speed, which do you like better? Because these standard deviations are so close, you could probably use either one. In terms of speed, which one do you like better?
I would definitely go with the 10 milliliter micropipette, or pipette.
The 10 milliliter pipette?
Yes.
Okay. So for today, because they're so close, you could choose, and yeah, we'll let you choose whether you want to go with the graduated cylinder or the milliliter pipette. You want to be consistent from now on, but it looks like in Jason's hands, he's good for both of them. I'll bet in a less experienced chemist, the 10 milliliter pipette would probably end up being more accurate, don't you think?
Absolutely.
All right, let's look at the 10 milliliter ones now.
Okay, we use the 20 milliliter beaker to measure out 10 milliliters. We got a good average.
Oh, good average. Let's see. It's 10.025. That's very good, huh?
But the standard deviation was awful.
Okay. So that means that's like a plus or minus, right?
Yeah.
So that means, oh, and look at the measurements. 10.2 all the way down to 9.4. So the values aren't very good, but the average is good, but that doesn't mean anything. I can go golfing and I can, on average, hit it where the cup is, but that doesn't mean I'll ever get it in the cup, right?
Right.
Okay. So average and standard deviation. Average is good here, but not standard deviation. What about the other two?
The volumetric flask,
Yeah?
we had a great average, 0.997.
Uh-huh.
It's right around where we want it.
Right?
And it had a great standard deviation,
Okay.
only 0.0029 grams.
And the 100 milliliter graduating cylinder. Good
Almost
average again, but
much higher standard deviation.
all right. So the tools we're going to use are what?
A micropipette,
Okay, for the 1 milliliter.
a 10 milliliter pipette for the 4 milliliter,
Uh-huh.
and a 10 milliliter volumetric flask.
For the 10 milliliter. All right, now, in this next step here, part B, determining the density of water, we're going to be, as in part A, it says there in 1, measure out volumes 1, 2, 4, and 10. So we need to have a 2 milliliter. Which one are you going to use for 2?
I could probably use the 1 milliliter micropipette and just aliquot 2 milliliters instead of just 1.
Okay, excellent. So he's going to use the 1 milliliter micropipette and aliquot it twice. Could you have done anything else? Any other options?
I could have used the 10 milliliter pipette
Okay,
and just measured out 2 milliliters instead of the 4
okay. But the micropipette's better, why?
because it's faster and it has a much smaller standard deviation.
Okay, great. So in the lab, you don't have to find the best tool for 2. You just choose a tool that you want to use for 2, right?
Right.
Okay, great. So here where it says determine the density, and it says use volumes 1, 2, 4, and 10 from part A, and we're going to determine the mass of those volumes, and it says you should measure again the mass of 4 samples for each measurement so that you can determine the standard deviation of the measurements. Well, we already did that for the 1, the 4, and the 10, right?
Right.
So now we just kind of have to add, for water, we just have to add the what? The 2.
2 milliliters.
The 2 milliliter. All right. So now how are we going to determine the density of water from this data? How are we going to do that? Make a graph.
Make a graph. We can make a graph, plot the averages.
Show us how to do that in Excel here.
So we would take the average mass and the volume. Just make this pretty. Average mass.
Okay. So the volumes you were trying to weigh out were 1, 2, 4, and 10. Is that right?
Yep.
Okay.
And then the average mass
Was for
1.99675
because that was the best for the micropipette,
grams.
right?
Correct. We're going to be using the mass from the 10 milliliter pipette for the 4 milliliters, so that's 3.
Wait a second. Where is it? Oh, there it is, right there, right? So it's
3.957
3.957. Okay.
grams. And then we will be using the average mass from the 10 milliliter volumetric flask for the 10 milliliter. So that was 9.97125 grams. And just to make life easier for us right now, you will have to make measurements in class.
We're going to do it too, right?
We'll do that too.
Okay, so we're going to measure out he's going to measure out 2 milliliters. How many times?
4 times.
4 times with the
Micropipette.
and then we'll have that too. So let's do that right now. Here, I'll leave you alone and we'll come back. We'll do that in a bit, okay?
Sounds good.
All right, so you got the 2 milliliters, correct?
Correct.
Excellent. Now we have all the averages. We have all of the averages and average masses lined up with the volumes, right? You made this over here, which was the 2 milliliter using the micropipette twice, and you got the average and the standard deviation. Okay, great. So now we're going to do what to determine, like it says in part B, determine the density of water. Now we know the density of water, that's not the question, right? But what we're trying to find out is, based on our measurements, what is the density of water?
That's right.
And the reason we're doing that is because we want to verify that this method is good first, and second, we want to know that we can use this method in the future, and we are going to use it right as soon as we're done with ethanol, right? Or with alcohol of some sort, right?
Right.
All right, so how do you determine the density from this data?
We would plot a graph. So we can highlight the data, go insert, look at it, press the scatter graph, and any one of these. I like this one.
That's the one you should use in this class, that's right.
So right now we don't know which one is on the x-axis and the y-axis. We want to make sure that the volume is on the x-axis and the mass is on the y-axis.
Why do we want the mass on the y-axis and the volume on the x-axis? Sorry, why do we want the mass on the y-axis and the volume on the x-axis? Is that what I said?
Right.
Why do we want it like that?
Because we want the independent variable on the y-axis or x-axis and the dependent variable on the x-axis or the y-axis.
Okay. Also, what?
When we plot the graph and find the trend line and get the equation for that trend line, the density will be the slope.
Okay. Of that line that fits that data, huh?
Right.
Okay, so
to find out which one is on the x-axis and y-axis, we're going to highlight this cell right there and turn it into 10.
So why did you do that?
So we can figure out if this column is on the x-axis or the y-axis.
And what was it on?
It's on the y-axis.
It was on the y-axis because this went up. The y-axis changed when you changed that value. Okay, so then, is that what you wanted?
No. So turn that back to 1, and we can
highlight this data right there. Just highlight that data right there. Click on those dots, and then you can drag these boxes where you want them to be. Is that right?
Right.
Okay, then drag that pink one over to there. Whoops, there we go, and then drag that blue one onto there. All right, so now our plot is right with the mass over here and the volume over here, correct?
Correct. So now,
how do we label this graph?
Go up to, well, first we go here.
Click on the graph first.
Then we can go to Chart Tools.
Uh-huh.
Then we can go here, and now we have space to make chart titles.
Okay.
So.
All right, so what is the y-axis? What should it be labeled?
It will be mass of water.
And then the units?
Sure you put it units, like that.
Okay.
And then this is going to be volume of water.
All right. Do we need a chart title?
Not for this.
It's nice, but you don't need one, right? Or do you need one?
Not for this lab, we do not.
Okay.
In a lab report, it could be good.
Okay, all right, great.
So
what about this thing. Do we need that?
No,
Why not? Because there's only one?
there's only one.
Okay.
So to find that trend line I was talking about,
Yeah?
you right button click
Uh-huh.
on this, and then you go to add trend line.
Okay.
And then you're gonna have all these options. We want linear.
Okay.
Then we can display the equation on the chart. Make sure you check that.
Okay, great.
And close it.
Excellent.
Here is our equation for that line.
So we're after the density. How does this help us with the density again?
The slope is the density of the water.
Based on our measurements.
Yep. Since the line is in the form y equals mx plus b, m is the slope, and that equals 0.998.
All right, so that is the slope for water based on our measurements, right?
Right.
Okay, now we have to find, according to this lab here, it says now we repeat it, but we're going to be finding the density of ethanol. Is that right?
Right.
Okay, so how are we going to do that now?
1, 2, 4, and 10 milliliters of ethanol.
That's right, 1, 2, 4, 10 milliliters of ethanol. Do we have to do it with 3 different tools?
Nope. We know which tools are the most accurate, so we can just use those tools again.
All right, so let's go get our ethanol. All right, so what is this here, this bottle?
This is ethanol,
Okay,
labeled ETOH.
all right.
It's kind of a standard labeling for ethanol in chemistry.
Okay, so now you're finding the density by?
Doing exactly what we did with water, measuring the mass of 1 milliliter, 2 milliliters, 4 milliliters, and 10 milliliters.
All right, excellent. And then we're going to make that graph again,
Exactly.
and the slope should be the density of ethanol,
Right.
which we're not sure of right now, right?
That is right.
Okay, so we'll leave you to it. And so you decided you're going to use the
micropipette for 1 milliliter and 2 milliliters. We'll be using the 10 milliliter pipette for the 4 milliliters and the volumetric flask for 10 milliliters.
All right, excellent.
I guess.
Okay, so looks like you have another graph up now. So you finished everything you needed to do there?
I did. So here we have the average mass and standard deviation for 1 milliliter using a micropipette.
1 milliliter of
Ethanol.
ethanol, yeah, and we can
Sorry.
see the averages, or the volumes, are a lot less, right?
Right.
Okay, or the mass is a lot
Mass
less.
is- Exactly.
For 1 milliliter, our masses are much lower. Okay,
Then this is 2 milliliters.
okay,
And this is 4 milliliters.
okay,
And over here, sorry, is 10 milliliters.
all right, so we need to change that to 10 milliliters, right?
Right. That real quick.
Okay, so now where did you get the values here? Are these the values that you plotted?
They are. So once again, this is the volumes that we plotted,
Uh-huh.
or that we used, 1, 2, 4, and 10 milliliters. And here are the average masses.
Okay, from the 1, 2, 4, 10. All right,
Yep.
excellent.
Make a trend line, go add trend line. Display equation on chart. Close it. And there we have the density of ethanol.
All right, 0.793 it looks like. Now, we don't really know if that's exactly correct. How could we find out, maybe?
Look at standards.
Okay, so look online, find out what it says under Wikipedia and such.
Yep.
All right, and if our value is way off, what would you suggest doing?
Redoing it.
All right, excellent. So we're done with part A and B in here, right? Part A and B are complete, is that right?
That is right.
So we repeated the procedure for ethanol and we found the density. Now we're on to the last part, part C, It says effect of a soluble salt on the density of water. Using a volumetric flask, make a solution that has 1 gram copper sulfate for every 10 milliliters of total solution. Measure the density of the solution by dividing the mass by the volume. All right, so I first have to make a solution, 10 milliliters, copper sulfate, right? 1 gram for every 10 milliliters of solution. How are we going to do that?
We will be using this volumetric flask for measuring out the 10 milliliters of solution.
Okay.
To weigh out the copper sulfate, we will be using this balance, putting a weigh boat on it, tearing it, and then weighing out the copper sulfate.
A gram of copper sulfate, and then what?
Then we will take some water, take that copper sulfate. Okay.
So you're going to put that copper sulfate into here?
Yes, but as you can see, it's kind of small.
Yeah.
So what we would do is, before we put any water into there, we would take a transfer pipette, fill it up with water, and kind of situate the weigh boat over the volumetric flask, and kind of, and pipette water over the copper sulfate and let it run into the volumetric flask until there is no more copper sulfate in the weigh boat.
Okay.